Today we are starting databases. Until now, our course platform could display courses and receive data from an API, but most of that data was stored temporarily inside an array. For example, we had, let me show you the cursor screen. We had this data. This works for learning, but it is not enough for a real application. When the server restarts, this data may disappear. We also need a way to permanently store users, courses, and enrollments. That is the job of a database. What does our course platform need to store? Imagine that we are building a simple course learning platform. We need to store three main things: users, courses, enrollments. A user maybe Sachin with an email sachin@example.com. A course may be React Basics with price rupees 499. An enrollment tells us that a particular user has joined a particular course. For example, Sachin enrolled in React Basics. The enrollment is important because one user can join multiple courses and one course can have multiple users. So let me show you the schema. This is our schema. It has users, enrollments, and courses. Three different tables are there. And one user can have many enrollments, and many enrollments can belong to one course. The enrollment table connects users and courses. Users table The users table stores information about people using the platform. So an example of user table can be this. This can be our users table. The ID uniquely identifies each user. Users may have the same name, but their IDs should be different. The courses table. The courses table stores the available courses. So this can be our courses table. Each course also receives a unique ID. Then enrollments table. Now suppose Sachin joins React Basics and Fast API Basics. We should not copy all the course information into Sachin's user record. Instead, we create enrollment record. So this can be enrollments table. Let us understand the first row. User ID equal to 1, course ID equal to 1. User number 1 is Sachin, course number 1 is React Basics. Therefore, Sachin is enrolled in React Basics. The third row tells us Priya is also enrolled in React Basics. This structure allows one user to join many courses. One course should contain many users. This is called a many-to-many relationship, but remember the term is less important than understanding the structure. What is SQL? SQL databases store information mainly in tables containing rows and columns. Examples include PostgreSQL, MySQL, SQLite, Microsoft SQL Server. Our course platform fits naturally into SQL table. So these tables are users, courses, and enrollments. SQL databases are useful when the data has clear relationships. For example, which course has Sachin joined? How many students joined React Basics? When did Priya enroll? Is the enrollment active or cancelled? Because users, courses, and enrollments are connected. A relational data SQL database such as PostgreSQL would be a strong choice. What is NoSQL? So we are let's summarize SQL once. So these are the examples of SQL database: PostgreSQL, MySQL, SQLite, Microsoft SQL Server. Now, what is NoSQL? NoSQL databases often store data as flexible documents rather than fixed tables. MongoDB is a popular example. A course document might look like this. Its example is MongoDB, and in this, one document can look like this. This resembles a JavaScript object or JSON response. NoSQL can be useful when the data structure changes frequently. Different records may contain different fields. The application works naturally with document-like data. Very flexible storage is required. In these cases, NoSQL can be useful. Let us compare SQL and NoSQL for our platform. So SQL approach, there will be three tables: users table, courses table, and enrollments table. The relationships are clearly defined. We can easily ask, show all users enrolled in course 1. Now consider NoSQL approach. We could store a document like this. So SQL approach for our courses. Uh, so three tables will be there: users, courses table, and enrollments table. Now let's come to NoSQL approach for our courses. It will contain this kind of data. We could store a document like this one. This appears simple, but suppose the title of React Basics changes. The title may have been copied into hundreds of user documents. Updating every copy can become difficult. In SQL, the course title exists in the courses table. The enrollments table only stores the course ID. Therefore, we update the course title in one place. So, which database should we choose? For this course platform, I would start with PostgreSQL. The reason is simple. Users have, so I would go with SQL approach for our courses because users have structured information and the courses have structured information. Users and courses have clear relationships, and enrollments connect them. And we may later add payments, certificates, lesson, and progress. That does not mean SQL is always better than NoSQL. It only means that SQL fits this particular problem naturally. The correct question is not which database is the best. The better question is which database fits the structure of my application. Now let me show you the final schema. The final schema will look like this. Users will have three fields: ID, name and email. Uh, and enrollments will have five fields: ID, user ID, course ID, enrolled at, and status. Courses, and one more table will be there: courses with ID, title, description, and price. And one user will contain many enrollments, and many enrollments will be there in one course. Now let's recap. Our database permanently stores our applications data. For our courses platform, we users store people, courses stores available courses, enrollments connects users with courses, SQL databases store related data in tables, and NoSQL databases commonly store flexible documents. Because our course platform contains clear relationships, PostgreSQL would be a practical starting point. Now, task for today. So, draw a database schema for a simple course platform containing users, courses, and enrollments. So, draw it on your copy, notebook, or you may use a tab, or you can use any tool like draw.io. That is also good too. Then add one extra table of your choice. It can be either payments, lessons, certificates, or course progress. Think about which IDs would connect the new table with the existing tables.